Hello, this video is about transfusion reactions. Transfusion reactions are what happen when you give somebody the wrong blood type in a transfusion, and the antibodies in the recipient's body attack the blood that you've just given them, and that causes the blood cells to agglutinate, and the agglutinated or clumped cells then get stuck in small vessels and capillaries and can lead to things like embolism and stroke. So it's very dangerous, and there's a basic rule of thumb that will get you by, but we're also going to talk about why that rule of thumb actually works. So the rule of thumb is never give a patient an antigen they don't already have. And remember, the antigens are things like A, B, or D. All right, so if a person has those antigens, it's safe to give them blood with those antigens. If a person does not have those antigens, then it's not safe, and that's what we're going to talk about. So to begin with, let's talk about the blood types and remind ourselves which antigens are on each blood type. So for instance, someone with O positive blood doesn't have A or B, but they do have the D antigen. Someone with O negative blood has no antigens. Someone with A positive blood has an A antigen and a D antigen. A negative blood, just the A antigen. B positive blood, the B antigen and the D antigen. B negative blood, just the B antigen. AB positive has the A antigen, the B antigen, and the D antigen. And AB negative blood has just the A and the B antigen. Now, to understand why we have transfusion reactions, it's important to talk about the antibodies that we actually have in our systems, not the ones that we're using to test blood types that we talked about in the blood type video, but the antibodies that we actually have circulating in our own bloodstream. So, to understand this, I need to tell you a little bit about the immune system. When the immune system is developing in fetal development and early infancy, it makes cells that have receptors that recognize every possible antigen. It does this by just scrambling the DNA and coming up with whatever receptor it can. And this way, whatever you encounter in the world, you're likely to have cells that will recognize that. But before those cells are allowed to leave the bone marrow or the thymus, where they're being produced, they have to be tested. And they go through a process called selection. And in that process, they are tested to see if they recognize self-antigens. Because if they recognize something that's in you, then that means when they're let out, they'll attack you. So any cell that recognizes self-antigens is automatically eliminated. Now, what happens in early infancy is that we develop antibodies that cross-react completely inadvertently. It has to do with bacteria in your intestine, normal bacteria in your intestine. But the antibodies that recognize those cross-react with our blood types. But remember, the immune system is not going to let us make cells or cells that make antibodies to things that are self-antigens. So if someone has no A or B antigens, they will make both anti-A and anti-B antibodies, because this is what our immune system does. It makes cells that can make antibodies to any possible antigen. Now in this case, because this person does not have an A or B antigen, it's safe to have the anti-A and the anti-B antibodies in the bloodstream because those won't attack anything. There is no antigen for them to recognize. Someone with type A blood, whether it's positive or negative, cannot have antibody A, can't have anti-A because the anti-A will agglutinate or recognize and clump the A antigen. So people with A blood types only have anti-B antibodies. Someone with a B blood type can't have anti-B, but they can have anti-A because there's no A antigen on their blood types or on their blood cells. And someone that has AB blood can't have the antibody A or antibody B because either of those antibodies would cause problems. So they have neither of those antibodies circulating in their bloodstream. Now, I'd like to point out that it doesn't matter whether the person has the D antigen or not. The only antibodies that we make universally across the board because of these intestinal bacteria are antibody A and antibody B. So we all do that unless we have the antigen that matches that antibody, in which case we do not make it because then it would harm ourselves. But the D antigen we do not make antibodies to. And that's why I didn't separate the blood types over here, because whether it's type O positive or O negative, they're going to have the same antibodies. So with the exception of a bad transfusion or something I'll talk about at the end of this little lecture called hemolytic disease of the newborn, there is no anti-D antibody. All right, it's just there in the lab to help us determine whether the person has positive or negative blood type. All right, so let's take a look at this and see what happens if I give someone who has O positive blood, I give them A positive blood, then I'm giving them the A antigen and their anti-A antibody will attack it, and that will cause a transfusion reaction. If I give somebody with type A blood, either type, if I give them type AB blood, then the A antigen is fine because there's no anti-A antibody here. But the B antigen in AB blood is going to be attacked by the anti-B antibody. Okay, so the reason that we don't introduce something that the person doesn't already have, an antigen that the person doesn't already have, is because they have antibodies that will specifically attack that or agglutinate that. Okay?